Okay, here are the notes for lesson 1-6, measuring angles. First of all, of course, when we're talking about angles, we've got to know what an angle is. The technical definition is it's the opening between two rays. That's a real technical definition here, but basically, if you have one ray where there's an endpoint and it goes on forever, that's one ray, and here's the other ray. And it's this opening is the whole entire thing is the angle, and that's the angle opening that we would measure. Okay? Now we've got a picture here that has an angle here. This right here is the symbol for angle. And we are going to list this particular angle here. It says angle TBQ. TBQ. Now it is important the way you list the three letters. This could have been also listed as angle QBT. You go from Q, then to B, then to T. Because there's the number 1 in the middle of it, it could have been called angle 1. And it also could have been just gone with angle B, because that's where the angle is formed. Okay. Angle addition postulate is very similar to segment addition. If I add two smaller angles, I get the big angles. So I'm just going to look at this one picture here. I'm going to basically say that this angle here in yellow, add it with this angle here in pink, will create the entire big angle altogether. So angle addition means angle in yellow AOB plus, and of course that's why we have angle addition. The pink angle, angle BOC, is equal to the entire angle, which is A to O to C, AOC, and that is angle addition. Okay, these angles have an opening measurement, so this might be 60 degrees, this might be 100 degrees, and then if I ask you what are they combined, you just go 100 plus 60. Acute angles, right angles, obtuse angles. Acute angles are less than 90 degrees. And I'm just going to quickly draw an example of an acute angle. A right angle is equal to 90 degrees. And I will draw a 90-degree angle. That's basically a perfect turn. And you are going to see this symbol right here. It's basically this red box. And whenever you see that red box, that's exactly 90 degrees. Okay, and that's considered a right angle. And an obtuse angle is between 90 and 180. It's obviously bigger than 90 degrees, so I'm just going to draw an obtuse angle here. This opening here to here is bigger than 90 degrees. And this is an unusual word, a straight angle. Straight angle is basically equal to 180 degrees. When you draw it, it looks just like a straight line. Remember, an angle is two rays, so I'm going to draw this one ray here, and then with my red pen, here's the other ray. Together, it just looks like a straight line. But this opening from here to here is 180 degrees, thus making it a straight angle. Okay. Some other important terms here, complementary angles and supplementary angles. Complementary angles, notice there's the S, supplementary angles. You're going to have two angles. Complementary angles are two angles, and I'm going to use the symbol, angles with an S, that add to 90 degrees. So I'm going to draw a picture of it. So here is one angle. I'll put an angle 1 there. And then another angle just right next to it. And I'll call this angle 2. But if I add angle 1 and angle 2 together, they form 90 degrees like this. And those would be called complementary angles. Supplementary angles are two angles that add to 180, and you're going to see 90 and 180 throughout geometry here. So I'm going to just draw a visual of this. I'll make an obtuse angle here, angle 1, and then together with this angle 2 here, they would form 180 degrees or a straight line. Okay, and we would call those supplementary angles with an S. Vertical angles are, and we will see a lot of these throughout geometry, are opposite angles formed by intersecting lines. So we're going to show this in a picture. Alright, so if I draw this line here, and here's another line that intersects, you'll notice when they intersect, there's 4 angles here. Angle 1, angle 2, angle 3, angle 4. And so there are a pair of angles that are called vertical angles. In this picture, angle 1 and angle 3 are considered vertical, and angle 2 and angle 4 are considered vertical. They're directly opposite each other. So top, bottom, left, right. Now normally when you see the word vertical, you would think something that goes straight up and down. It could be the left and the right, and those are also considered vertical. 2 and 4 are also considered vertical angles. Okay, moving on to the next page here. Let's continue on. This is 1A. Name angle, that's the symbol, CED 2 other ways. So we've got this picture here of a roller coaster. I don't know what that's about. But here's angle CED in pink. C, then go to E, then go to D. Well, I can write that 2 other ways. I can actually put this in reverse. I can start at D, go to E, go to C. So I can go D, E, C. Or because they put the number 2 in this picture, I can say angle 2. Okay? Critical thinking. Would it be correct to name any of the angles angle E? Would this pink angle be okay to call it angle E? And that is no. Because angle E could be the pink angle, it could be the yellow angle, it could be the combination of pink and yellow because E is right there in the middle. So when you see a bunch of lines attached with letter E, you don't want to just say angle E. At this situation here, you're going to need to use 3 letters. So if I want the pink angle, D, E, C. If I want the yellow one, A, E, C. Okay, don't just say E. That's not going to be good enough. Number 2, classify this angles. Obviously, you got a picture of protractors here. Find the measure of each angle AOC. So we'll look at where AOC is and classify it as either acute, right, obtuse, or straight. All right, so if I look at it carefully, here's letter A, go to O, go to C, angle yellow here, AOC. If you follow along with this, this yellow angle is an acute angle. It is less than 90 degrees. If you look at the protractor here, it will say it's actually 60 degrees right there, if you look carefully at it. It will also say 120. So when you see the 60 and the 120, it's kind of like, well, which angle do you pick? Well, this yellow angle, AOC, is the 60 degrees. So now why is the 120 there? Well, it could have been this angle here in pink. They could have said this way. And the protractor doesn't know if you're measuring the yellow angle or the pink angle. You've got to know as a student that I got an obtuse angle that's bigger than 90 degrees, and that's the 120. Notice 60 plus 120 adds up to 180, a straight line. Okay, let's look at number B here. What should we classify? AOC again, A to O to C. Well, that angle is a pretty big opening, and that angle would be called obtuse. All right, notice the angle is right there in the middle, and we will talk about how to use this protractor correctly to get those measurements. Okay, number 3 here. If the measurement of angle DEG, first of all, this little M here doesn't mean a point, this means the measurement. And so they're asking for how many degrees something might be. If the measurement of angle DEG is 145 degrees, so DEG, this is a 145 degree opening. From here to here, it's 145 degrees. Figure out the M for measurement of GEF. So basically, what is the measurement of this yellow line there? Well, if you'll notice, this 145 and the yellow angle form a straight line all the way across, just like any protractor, all the way across, and you will see this is 180 degrees. So in order to figure out the yellow angle here, GEF, you just take angle GEF is simply 180 minus 145, and this would be 35 degrees. Okay, 35 degrees. All right, moving on. It says name an angle or angles in the diagram that is supplementary. So you got to know the difference between supplementary and complementary. This is the previous page. Supplementary are two angles that add up to 180, forming a straight line. So if we have this first problem, part A, DOA, I'll do that in pink. I need an angle that, along with the pink angle, it would form 180 degrees, a straight line. And I could use this angle all the way over here. I'm going to use pink again. I'm going to go A to O to B. If you notice both pink angles together, they form a straight line. So the answer for this one is angle AOB. AOB and DOA are supplementary. They make a straight line. Let's see if I can use a different color here. Let's go blue maybe here for the next problem. EOB, E to O to B, and I want to look for the other angle that is supplementary to this. There's actually two answers here. You can use this angle here, D to O to E. That would work. Angle D to O to E. Notice your two blue angles form a straight line. Or you can ignore this blue line here and go C to O to B. And notice again you have a 180 degree straight line formed by the two angles. So this could also be angle BOC. Okay. We're going to skip number 5, but I just want to mention a few things in terms of symbols. Just a reminder here, this symbol right here is congruent, so basically saying angle 1 is congruent to angle 3. This box here in the picture is 90 degrees. And then they've got these kind of small little arcs here. Now the previous lesson, if you wanted to show two segments are equal, you would just put a tick mark, 3 inches there, 3 inches here. With angles, they just put these little arcs. And so you're saying angle 1 is equal to angle 3. So maybe if this is 50 degrees, I'm just making up a number, then this angle also must be 50 degrees because I see the tick marks. Okay, and that's the tick mark to say that angles are equal.